Hello, this is Chunjong Park from the University of Washington. In this talk, I will present our work on building context-augmented conversational agents. This work is done when I was interning at Nokia Bell Labs with Chulhong, Sourav, and Fahim. Conversational agents are widely used in smartphones, cars, and smart speakers. However, most of commercial conversational agents are oblivious to user situational context, missing opportunities to provide more adaptive responses, interaction style, and being more proactive. For example, when a user asks to check her messages, the agents can hide private information when others are around and only reveal message contents when the user is alone. However, detecting ambient context without disrupting users' interaction is quite challenging. First of all, we're not fully aware when and how long is the right moment to sense the ambient context. To explore potential opportunities, we conducted an observational study. We recruited 10 participants and asked them to use Amazon Alexa. Each participant asked 5 queries. We found that there were 1.29 seconds gap between the wake-up word and the query. We believe that we can leverage this opportunity because it does not disrupt users' current usage and the audio segments are not overlapped with the user's speech. From the previous study, we found that our data segments should be around 1 second. However, most of the public audio dataset has audio segments that are around 10 seconds. Furthermore, most of the data are weakly labeled, in which we do not know exactly when the events occurred within that audio segment. To solve this issue, we curated Google's audio set so that the data are strongly labeled in 1 second granularity. We use Amazon Mechanical Turk to curate audio set. After filtering out segments that the Turker didn't reach to a majority agreement, our dataset has 57,000 audio segments for 17 sound events. We released our curated dataset in the URL shown in the slide. Please visit our website if you are interested. Using the curated dataset, we built an ambient context classifier. We first chose target events which are common in indoor environment with multiple people. Then, we used VGG-ish model as a feature extractor and appended 5 fully connected layers to classify the ambient context. Our model achieved 0.8 F1 score and 360 milliseconds of latency when running on a Raspberry Pi. We further compressed our model using knowledge distillation for an on-device inference to lower the latency and preserve the privacy. Our compressed model achieved 0.73 F1 score, which is lower than the original model. However, the latency is significantly reduced to 10 milliseconds on Raspberry Pi. Please refer to the paper for technical details. In summary, we present a way to build a context-augmented conversational agent. We believe that the context recognizer will be an integral part in the next generation conversational agents. Thank you for your attention and feel free to reach out if you have any questions. Thank you.